Hi, so today we are going to finish up the second part of the notes on biochemistry, and this part's going to focus on chemical reactions. So today in class we spent a lot of time looking at atoms and how they were structured and making sure we could really determine the number of valence electrons. So just as a review, remember that valence electrons are the ones in the outer shell, and those are going to be the ones that are involved in these chemical reactions that we talk about. So before we start talking about chemical reactions, let's talk about some of their properties. So physical properties observe and describe matter. So you're talking about the state of matter. Is it a solid? Is it a liquid? Is it a gas? What color is it? What's its mass? That kind of stuff, okay? It does not change the type of matter. So you can go from like solid ice to liquid ice and you still have water, to liquid water and you still have water. It's still H2O. You haven't changed what you have. So melting and freezing are both examples of physical changes. Chemical properties, on the other hand, change when you undergo a chemical reaction. So they describe the reactivity of the substance. So when we talk about things being stable or unstable, that's what we're talking about with chemical properties. Are they going to react with something else or are they not? Burning is a big one. The ability to form bonds is another. And then these bonds are connections made between atoms that share or transfer electrons. So connections made between atoms that share or transfer electrons. The goal of forming chemical bonds is so that all of the atoms involved in the chemical are stable. So every atom has to be stable, meaning that it has 2 electrons in the first shell and then 8 in any subsequent shells that you have. Okay? All right. So when we talk about chemical reactions, we have 2 parts of a chemical reaction. We have the reactants, which are the starting materials, and we have the products, which is what you're making. So when you look at a chemical reaction, these materials here, the carbon dioxide and the water, are the reactants. The H2CO3, which is bicarbonate, it's carbonic acid, H2CO3, are the products. That's what you made. So CO2 plus H2O gives you this acid, which is carbonic acid. Reactants label products. Reactants, what you start with, CO2 and H2O. Products are what you get, H2CO3. And the same is true with this reaction. We have H2 and we have O2, and those come together to form water. Reactants are what you're starting with, the H2 and the O2, and you're producing or you're making water. So make sure you have those labeled on your sheet. So when we talk about chemical reactions in organisms, we're focusing on metabolism. Metabolism are all of the chemical reactions in your body. So when you're breaking down food, when you're breaking down that food for energy, when you're making proteins or when you're making lipids, whatever you're doing, all of the reactions count towards your metabolism. So metabolism are all of the reactions in your body. We classify reactions in biology by 2 different ways. One is synthesis reactions, and to synthesize something means that you're making something, so to make it bigger. So synthesis reactions do the same thing. They make larger compounds from smaller ones, so they make big compounds. They take 2 small things and they make something bigger. Photosynthesis is an example of that. All of you have told me already that carbon dioxide and water you put together to get glucose, so that's photosynthesis. You're taking carbon dioxide and water, which are 2 small molecules, and you're putting them together to make something bigger, which is glucose. Decomposition reactions are the opposite of that. They make smaller compounds from larger ones. So you start off with a big compound and you get small ones. And cellular respiration is an example of that. And cellular respiration is when you take our food and you break it down and release carbon dioxide and water, and then the most important thing is energy. So those are the 2 main ways we classify reactions in biology. Either synthesis, where you're making something, or decomposition, where you're breaking it down. Okay, so we're going to focus on the different types of compounds that we have, and there's 2 main types of compounds in biological organisms, and one is formed by ionic bonds. And bonds are formed when electrons are transferred between atoms. So one atom gets an electron and the other one loses it. So what that forms is an ion, which is a charged atom. So an ion is an atom that has either gained or lost an electron. It is either gained or lost an electron. So we have cations, which are positive ions. So positive ions are ones that have lost electrons. So you have more protons that are positive than electrons that are negative. So they have lost electrons. Anions are the opposite. They are negative ions. Negative ions are formed when atoms gain electrons. So now they have more electrons than protons. More electrons than protons. So more negative than positive. So their overall charge is negative. Okay, so let's take a look at this example. Sodium, this is the nucleus. And if you remember, hopefully you remember, there's protons and neutrons in the nucleus. The first shell has 2 electrons. The second has 8. And then the third has 1. Okay, because there's 11 electrons altogether. Okay, so 2 in the first, 8 in the second, so that's 10, and then you have 1. So we talked today in class about how that makes that atom unstable. So this has 1 electron. That's going to form a bond with chlorine. So chlorine has 17 electrons. So 2 in the first shell, 8 in the second, so that's 10. So the third shell is going to have 7 electrons in it. So it needs 1 more. So both of these are unstable. So in order to make them stable, remember, which is the goal of a compound, is to make the atom stable, sodium is going to lose an electron and give it to chlorine. So you can see here, represented by this arrow, that sodium is donating its electron to chlorine. So now sodium only has 10 electrons, still has 11 protons, nothing happened to the protons. So its overall charge is +1. It's a cation. Chlorine is now called chloride because it's an ion. It has 18 electrons instead of 17, which is what it started with. If you see over here, it now has 18, so that charge is -1. So it's an anion. Overall, these charges have to equal 0. So +1 and -1 equals 0. You still have to have an overall neutral, like we started off neutral here, and we started off neutral here. Your whole compound also has to be neutral. Okay? So that's how you form ionic compounds. One atom, usually a metal, so on the left side of the periodic table, donates an electron to a nonmetal, which is on the right side of the periodic table. That's an ionic compound. Okay, the other type of compound that we need to talk about are covalent compounds. Covalent compounds are also making atoms stable, but they're doing so by sharing electrons instead of transferring electrons. So they're sharing electrons. They form compounds that are also called molecules. So if you see the word molecule, that's referring to a compound that has been formed with a covalent bond. And there's a couple different ways we classify them. One is nonpolar, and that's when the electrons are shared equally. And then, for example, oil or butter or anything that doesn't dissolve in water is nonpolar. And then we have polar covalent compounds, and that's when the covalent bonds are not shared equally. So one electron or one atom has the electrons more often than the other, and water is an example of that. We're going to come back to these, but just make sure for now that you know these definitions because they're going to be really important with the next part of the unit. All right, so let's look at the formation of hydrogen. So H2 is a compound formed by a covalent bond. So hydrogen only has 1 electron. So it has 1 electron in its outer shell, in each outer shell. If you remember, the first shell of electrons only needs 2 electrons. So it only needs 1 more in order to be stable. But neither one of them has enough power to actually take it from the other, so they share. So now these electrons are going to spin around this atom for part of the time, and then they'll spin around this hydrogen part of the time. So they form a molecule called H2. Okay, so they are sharing these electrons. So now part of the time this hydrogen will have 2, part of the time this hydrogen will have 2. So now it's a stable compound. Okay, that's all the notes for today, so make sure that you have your note sheet filled in. I would like you to write 2 questions at the bottom that you have about the notes that you've taken today, and we'll talk about those in class on Monday. Have a good weekend. See you then.